Episode 29, AI Retrieval-Augmented Generation at Scale, How Senior Engineers Build Production RAG that Actually Works. Welcome back to Agentic AI World. I'm your host, and today we're diving deep into one of the most asked about topics in AI engineering interviews right now, building Retrieval-Augmented Generation, or RAG, at production scale. If you've been to any senior AI engineer interview in the last year, RAG has come up. But most candidates talk about RAG like it's a weekend project. Today I'm going to show you how senior engineers actually think about it. Let's start with the foundation. RAG exists because LLMs have two fundamental problems. They have a knowledge cutoff, and they hallucinate. RAG solves both by fetching relevant, real-world context at inference time and injecting it into the prompt. Simple idea, but scaling it? That's where it gets hard. The basic RAG pipeline has three phases: indexing, retrieval, and generation. Let's go through each one like a senior engineer would in an interview. Indexing is where most people make their first mistake. They chunk documents naively. Just split every 500 tokens. Done. But in production, chunking strategy is a first-class design decision. Semantic chunking, where you split on meaning boundaries rather than token counts, dramatically improves retrieval quality. You also need to think about chunk overlap, metadata enrichment, and whether your chunks are the right granularity for the questions users actually ask. A good rule of thumb: your chunks should be small enough to be focused, but large enough to have context. Somewhere between 200 and 800 tokens, depending on your domain. Embeddings are your next decision. OpenAI's text, embedding 3, small is a solid baseline. But for specialized domains, legal, medical, financial, domain-specific fine-tuned embeddings often outperform general models significantly. In an interview, always mention that embedding model choice is a workload-specific decision, not a one-size-fits-all answer. Now, retrieval. This is where production RAG diverges sharply from toy RAG. Basic vector similarity search, cosine distance against a pinecone or Weaviate index, works fine for demos. But at scale, you face several hard problems. First, recall versus precision. Pure semantic search can miss exact keyword matches. Pure keyword search misses semantic equivalence. The production answer is hybrid search, combining dense vector retrieval with sparse BM25 or TF-IDF retrieval, then re-ranking the combined results. Libraries like Cohere's re-ranker or cross-encoders give you a second stage that significantly improves the final top K quality. Second, latency. A full vector scan over 10 million documents is expensive. Solutions include HNSW indexing for approximate nearest neighbor search, query caching for common queries, and pre-filtering by metadata to reduce the search space before hitting the vector index. Third, the lost in the middle problem. Research shows LLMs are worst at using context placed in the middle of a long prompt. So when you retrieve 10 chunks, the order matters. Put the most relevant chunks at the top and bottom, not the middle. This is a small change with measurable impact. Now generation. The common question is, how do you handle conflicting information between retrieved context and model knowledge? The senior answer is, you build explicit conflict resolution into your prompt. Tell the model to prioritize retrieved context, flag conflicts explicitly, and never invent citations. Let's talk about the system design layer. A production RAG system needs more than a retrieval pipeline. It needs an evaluation harness. You need to measure retrieval recall, context precision, answer faithfulness, and answer relevance separately. RAGAS is a popular framework for this. Without evaluation, you're flying blind when you try to improve the system. It also needs observability. Log every query, every retrieval result, every final answer. Track which chunks get retrieved most. Surface low-confidence answers for human review. This telemetry is what lets you iterate. And it needs fallback handling. What happens when retrieval returns nothing relevant? You need a graceful degradation path, either a clarifying question to the user or a carefully hedged response that acknowledges the system doesn't have enough information. One advanced pattern worth knowing: Agentic RAG. Instead of a single retrieval step, you give the LLM the ability to issue multiple retrieval queries, reason about what it found, and decide whether to search again with a refined query. This is what separates simple RAG from truly intelligent retrieval systems. Tools like LangGraph and LlamaIndex support this out of the box. Another pattern, hypothetical document embeddings, or HyDE. Instead of embedding the user's query directly, you ask the LLM to generate a hypothetical answer to the query, then embed that hypothetical answer and use it to search. The intuition is that a hypothetical answer lives closer in embedding space to real answers than a short question does. In practice, this improves recall for complex questions by a significant margin. Let me give you the interview framework. When asked to design a RAG system, structure your answer in 5 parts. 1. Define the use case and requirements: latency, scale, domain specificity. 2. Describe your indexing pipeline, chunking strategy, embedding model, metadata schema. 3. Describe your retrieval pipeline, hybrid search, re-ranking, pre-filtering. 4. Describe your generation layer, prompt design, conflict handling, output validation. 5. Describe your evaluation and monitoring strategy. If you cover all 5, you're thinking like a senior engineer, not a junior who's done a LangChain tutorial. Common interview questions in this space. How would you handle a RAG system where users ask questions in multiple languages? Answer: multilingual embedding models like Sonar or multilingual E5, combined with language detection and language-specific chunking. How do you handle documents that are updated frequently? Answer: incremental indexing pipelines with document-level versioning. Delete then re-index at the document level, not the chunk level, to maintain consistency. How do you prevent the RAG system from leaking sensitive documents to unauthorized users? Answer: document-level access control enforced at retrieval time, not just at the application layer. Filter by user permissions before returning chunks. Here's your takeaway for today's episode. Most candidates can describe basic RAG. Senior engineers can describe why each design decision was made, what trade-offs it involves, and how they measure whether it's working. That's the difference between getting an offer and not. RAG is not a feature. It's an architecture. Design it like one. That's a wrap on episode 29. Next episode, we'll cover AI caching architectures. How to build smart caching layers that make production AI systems dramatically faster and cheaper. If you found this useful, subscribe to Agentic AI World and leave a comment with the topic you want covered next. See you in the next one.